Alright, so this is the CAD for the robot Firefly from Team 118, the Robonauts. This robot competed in this year's Reefscape game, 2025 FRC. And as an introduction, overall, Firefly is an extremely well engineered robot. It's capable of excelling at every part of the game, from fast cycling. It has a versatile ground intake. It's able to handle perpendicular coral. It has quick algae extake, and it also executes an extremely fast climb. And over the course of the season, this robot helped Team 118 obtain 7 blue banners and a win in the Milstein division. And their specific engineering approach combines innovative mechanical design, and they use complex electrical systems, auto software, and also lightweight materials. And I'm just going to discuss how this robot works by explaining each one of the subsystems. So first, I'm going to take a look at the intake of Firefly, which is the key feature of how the robot is able to cycle quickly. And the intake allows the robot to pick up coral in multiple orientations, including perpendicular coral, which is something a lot of teams struggle with. The ground intake is made of non-compliant rigid rollers, as you can see here, 3 of them. This is because like the goal of a ground intake is for speed and control, not for gentle gripping. So the intake relies on geometry and funneling through this part right here to be able to get the coral up into the intake. And so, like the precision of having compliant rollers for the ground intake is not necessary, and instead, speed is more important. And using rigid wheels also allows the coral to have no chance of getting stuck in the intake. And so, in short, Firefly is like coral ground intake uses rigid, non-compliant wheels to just like aggressively pull in the coral and reorient it through this tube that eventually goes up into the arm. Um, and compliant wheels are reserved for the end effector, where the coral actually goes to in the end. And here, the robot has a vertical belt, which twists 90 degrees through this part here to guide coral into the rollers. So if a vertical roller gets caught here, it will twist horizontally with this belt right here, and it'll just go straight in. And yeah, just to move the coral into the intake, a set of these 3 rollers are used, along with cat tongue tape to make sure the coral just goes quickly through. And a main feature of the intake is how the left and right sides are powered by separate motors. And here and here. And that's in order to make it spin in opposite directions. And this just allows the robot to align the coral properly into the intake. And the intake is generally just kept super low on the robot. And it's routed through multiple pulleys, as you can see, um, that have low resistance. And it generally keeps like the center of gravity of the robot low as well. So another important system on Firefly is the algae ground intake, which is located at the back of the robot, so opposite side of the coral ground intake I just showed. And this intake basically just looks like 2 prongs, as you can see here, and these are actually rollers that are tilted slightly upwards. And to collect the algae, the rollers spin inwards and pull the algae into the space in between these 2 prongs. And the algae becomes like guided through these metal inserts on the sides, and it helps it control to make the algae reach the end effector, which is higher up. So it kind of like gets pulled in and then bounces upwards. And after it gets like into the end effector, it can be scored really quickly. This ground intake is extremely quick. And it's really useful because instead of relying only on algae already inside the robot or at set locations on the reef, um, Firefly can just like quickly recover algae from the floor, and that keeps cycle times really fast. And additionally, like the 2 prongs are spaced so that even if algae is not directly centered in between the two, if it's like kind of on the side, like let's say it's over here, it's still able to pick it up because they have separate motors, each of these rollers, so they can spin in opposite directions. So it'll, even if it's kind of on the side, it'll pull it inwards, and eventually in between the two, and it'll make the algae just shoot upward into the end effector. And yeah, I think it's really fun and like like one of the best innovations of this robot. And just to show, this is basically the end effector, the algae end effector that it gets thrown up to here. So this um, kind of swings downwards towards these two prongs here. So it flings upwards. This is down. It catches it, kind of just grabs onto it with these wheels here, and then it comes back up to so you can score the algae. So the next thing I'll look at is the lift and arm system. And this lift is driven by a Kraken X44 motor and is a single stage lift, able to reach up to stage 4. And unlike most elevators, which use an X60 Kraken motor, I guess they use an X44. And dissimilar to multi-stage lifts, this robot lift only moved when needed to reach higher levels because it is a single stage lift. And in this case, it only actually moves upwards in order to reach L4. So this means that it's able to stay still for lower levels and complete faster cycles overall. And this overall increases the reliability of the lift while simultaneously reducing weight and keeping the profile of the robot lower. And the arm itself is driven by a cyclodial gearbox with approximately a 50 to 1 ratio. And cyclodial gearboxes are known for their high durability, compact size, high torque, and that allows like the arm to move smoothly while keeping the motors low in the chassis. And the cyclodial gearbox is connected to the base of the robot, in this case using belts, these belts here. All right, so the next thing I'm going to talk about is the end effector. And the end effector is able to handle both coral and algae. So this is the coral one, and this big claw kind of thing is the algae one. And it's made of lightweight aluminum and polycarbonate that just allows for light, swift movement, so the top of the robot isn't too heavy. And yeah, so Firefly has two separate end effectors, as I said, one for coral and one for algae. And the coral end effector uses a combination of X belts inside of here and rollers to grip the coral. And this coral end effector is unique compared to most end effectors because the wheels are sectioned inside of the coral. So the coral actually goes like on top of this. So this would be inside of the coral. And that allows for swift in-taking and X-taking, and also allows the drive team to be able to see the coral for greater accuracy when X-taking it onto the reef. And the algae end effector is geared for more torque and uses wheels opposite to the coral intake. And Firefly uses generally just effective materials for the end effector to keep the robot within weight range. So the last thing I'm going to talk about is the climb. And the climb is center mounted, so it's mounted in the center of the robot, and it uses hooks and torsion springs to interact with the climbing cage. Um, Magnets are placed in the back here to provide resistance initially, which prevents the cage from like swinging backwards and the robot failing to climb quickly. And in the back here, there are also two sets of limit switches, and they provide automated feedback. So the first switch triggers the yellow light, and pressing both of them triggers a green light, which means the robot is fully latched and ready to climb. These wheels here were added to catch a swinging climb or a swinging cage, um, and that means they're able to climb a lot quicker in certain situations. And the climb was originally designed to be driver operated, but is now largely automated. And overall, this mechanism allows Firefly to climb in just 3 seconds, which is quicker than most teams. And thank you for listening to my brief overview on Firefly.